assume it's only from 0 to 2 pi. The x value is going to be pi on 6 and 7 pi on 6. Okay, now let me show you how to do this kind of question. For example, if I have sine square x minus sine x times cosine x equals to 0, and x is from, just say, is from 0 to 2 pi. Now to do this kind of question, I just make it clear. Sine square x is just equals to sine x square. Similarly, if I have sine cubic x, it is equals to sine x cube. So just follow this rule, but most importantly, sine inverse x doesn't equals to sine bracket power of -1. This doesn't happen. Don't be confused. This is the inverse x. So let's go back to the question. Now what's happened is we have to factorize it. In this equation on the left hand side, I can say there are two terms there, and each term is a multiple of sine x. So I can just put sine x bracket sine x minus cosine x equals to 0. It is similar. This is just similar. Write it down. To say if I have x squared minus x times a equals to 0, and I can rewrite it as x bracket x minus a. I factorize it by taking the x from here and here out and group whatever left in a bracket. We do the same thing here, and the difference is in the question we don't have a single x, we have a sine of x, sine x. But we can, it's simple algebra, we can do it. We still can do the same thing. The rest is easy. Once we have sine x bracket sine x minus cosine x equals to 0, then to solve x, sine x can be equals to 0. Also, sine x minus cosine x is also 0 from this term and whatever in the bracket there. And to solve this, x is going to be 0. From this step here, x is going to be 0, pi, and 2 pi. And to solve this, I have sine x equals to cos x, and sin x divided by cosine x equals to 1. Okay, and I have tan x equals to 1, and x can be basically pi on 4 and 5 pi on 4 using special triangles and unicircle, like what we did here. Okay, okay. 1 1 square root 2 is pi on 4 there. Okay, now the answer is 0 pi, 2 pi, and pi on 4, and 5 pi on 4. So there are 5 answers satisfies this equation. Okay. Okay. I think the tricky part of this equation, this question, is just this step. Okay. The idea is, well, let's okay, let's consider sine. Well, okay. Let me rewrite it again here. Say, if I rewrite it in this form, you maybe can if I write this form, it's easier to say. Okay, this is a minus sign, by the way, and here is a times sign. In both terms at left hand side of the equation, they are multiples of sine x. So as a result, I can put it in this I can take sine x out and put the rest in bracket, which is this form. What I did is I took sine x out and leave the rest in the bracket, which is sine x minus cosine x. Okay. Because if I take sine x out from sine x squared, I have sine x. And if I take sine x out from sine x times cosine x, and cosine x was left, so I have sine x minus cosine x. It's similar as what we did in year 10 quadratic equation. Sometimes we have x squared plus 2x equals to 0, and we can take the x out, so x, it is equals to x bracket x times bracket x plus 2 equals to 0, and your x is 0, x plus 2 equals to 0, and x equals to minus 2. So you have two answers, x equals to 0 and minus 2. What I did here is just similar stuff. I put it in this form, and sine x equals to 0 here. Okay, and whatever in the bracket has to equals to 0 to find the final solution. Okay. And well, when sine x equals to 0, x is 0, pi, and 2 pi. You will learn to do that later. If sine x minus cosine x equals to 0, then the whole thing, well, then I can rearrange it. It becomes like that, and when I group them both to the left hand side, it's become this, and which is tan x equals to 1, and I can solve this equation. So I will have 3 values there and 2 values there, and totally 5 values for this answer. Okay. uh, okay